All right, hi guys, it's day 8 and we're looking at block 2, algebra with medians, perpendicular bisectors, and altitudes. So we'll use those new vocabulary words to solve a couple of problems here. Short notes, so let's just jump right into this first problem. So it says the perpendicular bisectors of triangle ABC meet at point D. So here's point D. Okay, so our perpendicular bisectors, remember perpendicular means they form a 90-degree angle. Here's our symbol. Bisector means it's cut into two equal parts. So here's our perpendicular bisectors, each one. And this point D we haven't really talked about yet, but it actually is pretty important. That point right there is called the circumcenter. And that would be where the perpendicular bisectors meet. And that point is equidistant from the vertices. Okay, so that means that these three segments, this guy, and this guy, are all congruent because they're equidistant from the vertices. Okay, so that point goes back to the vertices. So it's not that the perpendicular bisectors themselves are congruent, it's the distance from that circumcenter point where they intersect back to the vertices. Okay, so that will help us solve the rest of this problem. Part A, it says find DB. Well, now that I know this information about the circumcenter, I can see that AD is 14, so DB should be congruent. Oops, also 14. The next piece, it says find AE. So I'm looking at AE up here. Now this one, we're going back to perpendicular bisectors thinking, knowing that ED will bisect this entire segment, so these two should be congruent. I have a total length here of 22, which makes it pretty easy to know, okay, this has to be 11 and this has to be 11. So AE equals 11. And then we're going to find ED. I'm going to switch colors here. So ED is the length of this perpendicular bisector. Okay, so I'm looking and I see two triangles. I see two right triangles. And then the hint here is to use Pythagorean theorem. So when I look at this triangle, EDA, I have a side length of 11, hypotenuse of 14, and I don't know this side right there, this leg. So I can use Pythagorean theorem. 11 squared plus x squared equals 14 squared. Solving for x. Square root both sides. X equals the square root of 75. That's fine, we'll just leave it there. Oh my gosh. Okay. All right, pretty straightforward first problem. Let's look at the second one here. So again, it says R is the circumcenter of triangle OPQ. So here's OPQ, R is the circumcenter. So that means that the distance from the vertices to that point is equal. So looking at my picture, these three segments are congruent. And that means that these guys are perpendicular bisectors. Okay, so each of these is congruent to each other, not necessarily all the way around. So let's look at what else we have. It says OS equals 10, okay? QR equals 12, put that on our picture. Labeling the picture is going to help you the most when you're doing any problems in geometry, so make sure you're labeling. And PQ equals 22, so I'm going to draw a segment out here, 22. Okay, so now we're going to use that information to find a bunch of other pieces. So I want you to try this one on your own based on what we did in the last problem, and now that you have some of the labelings on, and see if you can find all of these missing pieces. All right, so here's my work for that problem. Pretty straightforward. Now that we know what the circumcenter does and how it helps us find congruent pieces, just working my way around the triangle, labeling everything that I know to find those missing segment lengths. And then I did Pythagorean theorem for the last problem.